If you have ever walked into a job site and seen a fire alarm panel showing a ground fault or short circuit, you know the panic that can cause. These issues can shut down systems, create false alarms, and delay inspections, but they do not have to be frustrating. In this video, I am going to show you how to correctly identify, isolate, and fix ground faults and short circuits using a systematic method that actually works in the field. First, let's deeply understand the enemy. A ground fault occurs when any positive or negative conductor comes in contact with earth ground. This could happen from damaged insulation, pinched wires, or moisture intrusion. A short circuit is different. This happens when two conductors touch each other directly, such as a positive wire touching a negative wire. Unlike ground faults, shorts usually trigger immediate troubles or system failures. Before you even touch a screwdriver, you need to do some investigation. First, review the event history on the panel. This helps you confirm when the ground fault occurred and whether it is intermittent or constant. Second, speak with the facilities or building personnel. Ask them if there have been any recent roof leaks, water intrusion, or construction in the building. These situations often introduce moisture or damaged wiring, which are the most common causes of ground faults. To fix this, you need the right tools. You need a digital multimeter that has both resistance and continuity modes. You also need an insulated screwdriver for safety. If you have the system drawings, get them now, as they will help you locate devices. And finally, you need patience. Step 1 is to identify the circuit. You need to determine if the fault is on the SLC loop, the NAC circuit, the power circuit, or an auxiliary output. Begin isolating the fault by removing these circuits one at a time from the panel. After you remove a wire, wait and observe if the ground fault clears on the display. This confirms exactly which loop has the problem. Once the grounded circuit is identified, use your voltmeter to start testing. First, check for both AC and DC voltage on the wires. If no voltage is present, then switch your meter to resistance testing. Measure the resistance between the conductors and ground. If you receive a reading below 1000 ohms, chances are you have located the circuit containing the fault. The lower the resistance reading, the closer you are to the actual damage. Now, use the divide and conquer method. Make an educated split in the field. A good starting point is halfway down the run. Before you do anything, always label the incoming and outgoing conductors to ensure they are reconnected properly. Disconnect the device and test both sides. One side will show normal values, while the other will show low resistance. Follow the side with the low resistance readings and repeat the process until you find the exact spot of the damage. For short circuits, the process is slightly different. First, power down the circuit and disconnect the conductors. Switch your meter to continuity mode. This is the setting that beeps when wires touch. Trace the wiring until the continuity signal disappears. You are looking for physical damage, like staples driven through the wire, crushed conduit, or incorrect splices. If you are stuck, check the most common failure points. Look for device backboxes where the bare wire might be touching the metal. Check for moisture-filled conduit, especially in outdoor devices, and look closely for pinched wires under the mounting screws of devices. Here are some final pro tips. Most ground faults are caused by moisture, so check for leaks first. Never assume the problem is at the last device on the loop, and always check newly installed areas first, as construction damage is very common. With this structured approach, you can consistently correct these issues without guessing. If this helped you, please subscribe for more real-world fire alarm troubleshooting tips.